Hi guys. So we are going to be working on 11.2 angle theorems for triangles. Okay, so this can get a little bit confusing. The first concept that it wants us to understand is that if I take the three corners of any triangle, that means any triangle, and put them together, it's going to be 180 degrees. So, three corners of a triangle equal 180 degrees. Always, always, always. The other big, huge concept, actually, you know what? Let's do a couple of examples with the three corners equaling 180 degrees, and then we'll move on to the other big, huge concept, just so that you have an example here. So if I have a triangle like this, and I am told that this is 112 degrees, and I am told that this is, let's go with 35 degrees. The way that I solve that, because I want to know what this is my x, okay? I don't know what that is. The way I solve this is I go 120, 112 plus 35 plus x is equal to 180. You see that? 112 plus 35 plus x is equal to 180. Okay, so then I add together my 112 and my 35, and I get 147 plus x is equal to 180. I then use my algebraic mind and I subtract 147 from each side. I get a 0 on that side. I can't take the 7 from that 0, so I need to borrow. 7, 1. 10 minus 7 is 3. 7 minus 4 is 3. So x is equal to 33 degrees in this particular triangle. It works for every single triangle. It does not matter which one we have. Sometimes you will end up with this. They will give you a triangle like this, and they will put the little square in there. And they will tell you that, let's do the upper one first. Let's make that a, let's say that one's 15 degrees. And I'm going to make this y just so that we have a different letter, okay? So nobody gets confused. So, sorry, I need to move it up a bit. So what we end up doing is this. We have our 15 degrees plus our 90 degrees. That is a 90 degrees right there, 90. Plus the y. That's our three angles. 15, 90, y. Three angles. Equals 180. Because the three angles on a triangle always equal 180. I add these together. The 15 plus the 90, which gets me to 105. Plus y equals 180. I subtract the 105 from both sides. Get a 0 there. I cannot take the 5 from there, so I borrow. 10 minus 5 is 5. 7 minus 0 is 0. So I am left with y is equal to 75 degrees. Okay? Does that make sense? Freeze it if you need to. I'm going to move on to a different sheet of paper. Okay, so now we're going to do the other big thing that's in this particular section, which is the exterior angle. Okay, so, really? There we go. The exterior angle theorem. Okay, so this one is a lot more complicated to understand than the other one is, and I'm not going to be surprised at all if you got very confused by it very quickly. Basically, the idea is, here, let's do some definitions first, because this is full of definitions, and that's the only way that it works. Okay, so I have an exterior angle. Let me do this. Exterior angle. Oh, sorry, I'm slouching down. Exterior angle is outside the triangle. Interior angle is inside the triangle. Okay, the exterior angle is outside because exterior is the outside. The interior is inside because interior means inside. Now, what they keep talking about is they keep talking about the remote interior angles. So let's write that one down too. Remote interior angle. So those are the two angles that are opposite. So that means not touching. The exterior angle. So remember how in the book, it tore off all 3 pieces of paper for each of the corners. It ripped off one corner, it ripped off another corner, it ripped off the third corner. It laid them all down and it made a straight line. Do you remember that? That's what we're working with here. If I took this corner and this corner and I ripped them off, they would be the same as this right here. Because I could take this corner and put it here. I could take this corner and put it here. And then I would have all 3 corners next to each other, and it would make a straight line. Which means this corner and this corner is equal to this corner. So let me show that. This corner and this corner they both fit into this corner, okay? So what it's saying is, I'm going to write it at the bottom here. Yeah, we're probably going to end up with a whole nother sheet of paper so that we can put in examples. No, actually, you know what? I'll write it at the top and then we'll do the example at the bottom. How about that? Okay, so our exterior angle is equal to both interior angles, equal to both interior, remote interior angles. Okay, so the one exterior angle is equal to both remote interior angles. So let me draw that and show you what it ends up actually looking like. So if I have, not that one, if I have this, just like what I have up there, and I am told that this is equal to, let's say, 100 and, no, sorry, 100. Let me see. So if that one is, yeah, okay, 150 degrees. Let's say that's equal to 150 degrees right there. Okay, that is my exterior angle. So I know that this one is equal to, let's say 30 degrees. And let's have this one be equal to, I'm going to make this one a variable so that we actually have something to work with. 5x, I think that'll work out. 5x, okay? So that last one is equal to 5x. So let me make my x look a little prettier. There we go. Okay, so this tells us that we can set that 150 equal to the 5x, which is one of them, plus the 30, which is the other. Do you see? The exterior is equal to the 2 remote interior. All right. You with me so far? Now we have to do our algebraic stuff. First thing, easiest thing to get rid of is that 30. So since we added, it is added there, we are going to subtract to get rid of it. So minus 30 from both sides. That gives us a 0 there. 0 minus 0 is 0. 5 minus 3 is 2. And then we have the 1. We rewrite it. So I now have 120 is equal to 5x. The 5 is connected to the x by multiplication, so I am going to divide by it. Those 5's cancel each other out. I have my calculator. Always have your calculator. And 120 divided by 5 is 24. So x equals 24 degrees. Wait, that doesn't make sense. Wait a second, let me look at this. Okay, so I figured out what my actual problem was. The numbers that I chose were completely and utterly ridiculous. And so yes, x is 24. And if we plug it back into here, so we have the x. Oh, okay, so if we plug it back into here, so we have the 5 times x, I end up with this particular angle up here, the little itty bitty angle, being equal to 120 degrees. This is why we use protractors. So yes, the answer for x is in fact 24 degrees. The answer for what our missing angle that we don't have yet is in fact 120 degrees, despite it being tiny. Yeah, that's actually the correct measurements for all of it, although the triangle should not look like this. It should look here. I'll show you what the triangle for this particular problem should actually look like. It should look like this. That's what our triangle should actually look like. I completely messed up when I was drawing the thing. All right. So this is what the triangle that goes with this particular problem actually looks like. The math is fine. The math is just fine. It's just my drawing's off. Okay? So the math, this is exactly how you do it. And then the last step you have is you plug whatever you got for x back into your problem that you started with, because most of the time they will have an x or a y or a z or whatever letter they decided to have in both of the angles, not just in one of them. So, all right. If that is enough for you to understand how we're doing it, you can go ahead and stop watching now. If you want to watch the actual, I'm going to page 355 inside your book, and I am actually going to be working through the section. So, yeah, that does actually work. Okay. So on page 355, it has a triangle that it ripped apart, and it has angles A, B, and C. It ripped off each corner, and it put them so that it was showing them in a straight line. It does a very nice job of it. I don't really see the need in doing it myself. If you want to make a triangle and rip apart all the corners, go right ahead. That's fine. So what do you notice about, I'm at D. What do you notice about how the angles fit together around the point? Well, what we notice is they make a straight line. They make a straight line. Letter E. What is the measure of a straight angle? So what is the measure of a straight line? We know this. A straight line is 180 degrees. Letter F, describe the relationship among the measures of the angles in triangle ABC. What it wants us to say is all the angles together equal 180 degrees. That's what they want us to say. The triangle sum theorem states that for triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Justify your reasoning. Number one, it says, you can pause at any time if I'm going too fast, okay? I'm just going to go straight through this. Number one, it says, can a triangle have two right angles? So that means, can you make a triangle that looks like that? No. Why not? The angles are already at 180 degrees before even getting a third angle, because 90 plus 90 is equal to 180. So let me zoom in a little bit. Can I? Not really. Okay, sorry, that's a little well, whatever that word is, getting over there. Then I am going to do number 2. Describe the relationship between the two acute angles in a right triangle. So what it's wanting us to understand is that if I have a right triangle, I have already used half of the angle that I have available. I've already used half of it, because remember here we used all of it just because we had 2 right triangles. So here I already used half of what I have available. So the other side, the rest of the line, is going to have to be equal to 90 degrees. So when we put the other 2 together, we're going to have 90 degrees. So the other 2 angles will be equal to 90 degrees, because you need to make a second right angle. We made 1 right angle, we need to make a second right angle. Okay, so now I'm going to show you this mess that they have on page 356. This is, yeah, this is going to be fun. Okay, so we start with, like I said, pause it if you need to. I am flipping to something else. We start with drawing a triangle and labeling sides. So I have a triangle now, and I am going to label this as 1, 2, and 3. So that is my triangle. I have 1, 2, and 3. I am then going to draw a line through the bottom of it. Let me get a different sheet of paper. All right, so triangle, 1, 2, 3. Draw a line through the bottom of it. That line is going to be called A. Then it wants me to draw a line through the top of it that is parallel to A, which we are going to call, can I get it? That is going to be B. Okay, so I have a line A, I have a line B. They are parallel to each other, or at least as parallel as I can make them. So I now have angles 1, 2, 3, line A and line B. Then it wants me to extend the non-base sides. So this is the base. The line that is on A, that's the base. It wants me to extend the non-base sides. So I'm going to do that in brown so that we can see a difference. Or, yeah, the non-base sides. So we end up with that. And then I'm going to do the other one in, no, not green. Let's do, no. Let's use this yellow. And I'm going to extend that. So there. And is this a brown? You know, these cap colors do not look like what they actually are. Okay. So there we go. I extended it in both directions. They want us to call this one S and to call this one T. T. Okay. So we are then supposed to label these angles, which are in here, as angle 4 and angle 5. That's our next step, angle 4 and angle 5. You with me so far? We have this monstrosity going on. You can also see it inside your book. So angle 4, I'm comparing angle 4 to angle 3. So I am actually at F right now. Angle 4 and angle 3 are alternate interior angles. Okay, so alternate interior. Remember last section? Oh, no, wait. Dude, I'm wrong. It's not angle 4 and angle 3. It's angle 4 and angle 2 because this is the line that we're drawing on. So sorry. Angle 4 and angle 2. Angle 4 and angle 2. Let me go over that with a different color. Angle 2. Sorry. I am totally screwing myself up. Okay, so we're on line T. We're looking at T. 4 is on T, 2 is on T, they're alternate. We know that because they're alternate, because they're on different sides of this line T, that means that they are the same. So they're alternate interior, they are equal. G. Because angle 5 and angle, all right, so let's look at where we're going. We are on line S. On line S, I have 5 here, and I have 3 here. So it's 5 and 3. This is where our 3 is. 5 and 3 are alternate interior angles. They are also equal because that's just how alternate interior angles work. Okay, remember we did this previous section. Alternate interior means they're equal. Letter H. The 3 angles that lie along line B at the vertex are 4, 1, and 5. Note those 3 angles lie in a straight line. So angle, this is the measure of angle 1 plus the measure of angle 4 plus the measure of angle 5 is all equal to 180 degrees because it lies in a straight line. That's just how it is. Because the angles 2 and 4 are congruent and the angles 3 and 5 are congruent, you can substitute in measures. So we can do the measure of angle 1 plus the measure of angle 2, which we got from angle 4, they're equal to each other, plus the measure of angle 3, which we got from angle 5 because they're equal to each other, are equal to 180 degrees. This shows the sum of all of the angles in a triangle are 180 degrees. Boom. Number 3. How can you use the fact that the measure of angle 4 plus the measure of angle 1 plus the measure of angle 5 equals 180 degrees to show that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 equals 180 degrees? We literally just did this by using alternate, sorry if I'm blocking the screen, alternate interior angles. We can switch between the angles. Okay, so that's number 3. I need to get a new sheet of paper. I'm getting off of this one. Next one. Finding the missing angle measures in triangles. So it sits here and it just goes through what I was showing you before in the notes. Down at number 4, it wants to know what the measure is. We are given an angle of 71. We are given an angle of 56, and we are given K. Altogether, they are equal to 180 degrees. So I do on 71 plus 56 equals 127 plus K is equal to 180. I subtract the 127 from both sides. That gives me a 0 there. 180 minus 127 equals 53. So K is equal to 53 degrees. Next one, number 5. I am given 29 and 61 and the letter R. Okay, these are for a triangle. They go together. It is equal to 180 degrees. 29 plus 61 gives me 90, plus R is equal to 180. I subtract 90 from both sides. 90 minus 90 is 0. 180 minus 90 is 90. So R is equal to 90 degrees. Next page. I am on 356. We're just going to go straight down through it. Okay, so I have all of the interior angles, exterior angles, remote interior angles. We talked about all of those. We talked about which one of them is each of them. They have a nice picture at the top of the page. We're just going to move down. So it says the triangle theorem. I am at B. The triangle theorem states that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So letter C, we already know. Letter C. Angle 3 and 4 form a line. Angle 3 and 4 form a line, if you look at the picture that they have in the book. And so the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees because it's a line, and a line is 180 degrees. We can then go the measure. Okay, so D wants us to do this. D says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Okay, so that's what it wants. That's what it wants us to have. All right, does that, yeah. So basically you were filling in the measure of angle 3 in both places. Use the properties of equality to simplify the equation in D. And so what it wants you to do is it wants you to subtract out the measure of angle 3, because we don't really need that on both sides of the equation. So we can rewrite the equation as the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Okay? Does that make sense? We don't actually need the 3. I could go minus the measure of angle 3 to both sides, and it would just get rid of it entirely. So I can simplify it down to the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Okay, I have the exterior angle theorem states that the measure of an exterior angle is equal to the measures of its remote interior angles. Okay. Stop that if you need to. I need to move on to a new page. Number 6, sketch a triangle and draw its sketch a triangle and draw all of its exterior angles. How many exterior angles does a triangle have at each vertex? Okay, so this is how this works. I'm going to make this triangle. Okay, that's going to be my triangle. In order to make exterior angles, I have to make things shooting out on each side. So for this particular line, I could make one here and one here. You see how I just continued that line? For this particular line, I can make one here and one here. You see how I just continued that line? For this particular line, I can make one here and one here. Okay? That's every single line. I just continued the line. I continued going out the whole way so that it crossed across the entire thing. So the question is, how many exterior angles does each corner have? Well, this one has 2, this one has 2, this one has 2. So our answer to the question is, how many exterior angles does each one have? 2. Number 7. How many total exterior angles does a triangle have? 2, 4, 6. Over onto the next page. Using the exterior angle theorem. So it sits here and it gives us an example of using, just going through the entire thing and solving it using algebra. So we are going to go down to the bottom, and we're just going to go down to number 8. Number 8 says, find the angle measure of M and the angle measure of N. So I am going to go 5y plus 3 plus 4y plus 8 is equal to 146. Okay, because 146 is my exterior angle. That 5y plus 3 is angle M. 4y plus 8 is angle N. And now I just need to do things with this. So the very first thing that we're going to do is we're going to put all of our y's together. So we're going to take this 5y and this 4y, and we're going to go 5y plus 4y, which is going to give us, and then the 3 plus the 8 are going to go over here. And it equals 146. Sorry. Okay, so 5y plus 4y gives us 9y. Plus 3 plus 8 gives us 11. Equals 146. Easiest thing to get rid of at this point is the 11. So it's currently added. We are going to subtract, because that's the opposite. So minus 11 from both sides. That gives us a 0 there. 6 minus 1 is 5. 4 minus 1 is 3. And then a 1. So I have 9y equals 135. This is connected by multiplication. So I am going to divide. Divided by 9. That cancels out. I then end up with 135 divided by 9 equals 15. So y is equal to 15. I do not know what any of my actual angle measurements are yet. I have to go back to what I had before. So I have 5y plus 3. And now I know that it is that y is equal to 15. So I go 5 times 15 plus 3. 5 times 15. 5 times 15 is 75 plus 3, which is 78. So our measure for angle M is 78. Then I need to do, I am running out of space on here, so I'm going to do it all the way up here at the top. Okay. Then I need to do the 4y plus 8, where y is 15. 4 times 15 plus 8. 4 times 15 is, oops, no, 4 times 15 is 60. Plus 8 is 68. So the angle measure for n is 68 degrees. Okay. Then over on the guided practice. Yeah, okay. Let's go through the guided practice really quick. Okay, so first off, we have number one, we're just trying to find the other angle. We're already given 2 of the angles. So I have 78 plus 31 plus x is equal to, well, I guess it's an m, plus m is equal to 180 degrees. So I do 78 plus 31, which is 109, plus m is equal to 180 degrees. I subtract 109 from both sides. Get a 0 there. 180 minus 109 equals 71. Number 2. I have 126 plus 24 plus q is equal to 180 because it's always equal to 180. 126 plus 24 is equal to 150. Plus q is equal to 180. I'm going to subtract the 150 from both sides. So I end up with q is equal to 30. Sorry, up there it was m equals 71. And I guess I need to put the degree sign there. For number 3, what we end up having to do is this. We are given all of these interior angles to deal with, but none of them are actually given to us. They are all just given to us as equations to solve. So I need to sit here and plug in every single one of these and set it all equal to 180. Okay, so every single one of them gets plugged in. I then put all of my x's together. So 7 plus 2 is 9 plus 5. Oh, actually, okay, so the 5 and the 2 make a 7, so 7 plus 7. So I have 14 x's. Okay, I just took everything that had an x with it, the 7, the 5, and the 2, added them all together, and got 14. That's all. Then I have the 4, the 3, and the 5 because they don't have a letter with them. So I'm going to add them together. And I'm going to get 12 is equal to 180. Now, the easiest thing to do is to subtract the 12. It used to be added, so we're going to subtract it. 180 minus 12 is equal to 168. Then I have 14x is equal to 168. So I'm going to divide both sides by 14 because it had been multiplication. So now it is going to be division. And that gives us a 12. So I have x is equal to 12. Now, you would think that you're done, but you're not actually done yet. You now have to go back and substitute this into every single individual problem. So we have to go 7 times 12 plus 4. That's one of our problems. 7 times 12 is 84. Plus 4 is 88. So that's one of our angle measures. One of our angle measures is 88 degrees. I have 5 times 12 plus 3. 5 times 12 is 60. Plus 3 is 63 degrees. So that's another one of our angle measures. And our final angle measure is 2 times 12 plus 5 is 24 plus 5, which is 29 degrees. Let me see. So I got the 7x plus 4 from the t, the 5x plus 3 from the v, and the 2x plus 5 from the u. So, oh, sorry. I didn't realize I was off the screen for the 2x plus 5. This is just how you solve these problems, okay? There's not any, you just keep doing it over and over and over and over and over again. So for the next one, number 4, we have, okay, n plus 1/2 n plus 1/2 n is equal to 180 degrees. And I know that you're looking at this and you're going, what? But 2 halves make a whole. So I can put these two n's together to make one whole n. And then I have an invisible 1 in front of this one. So I actually have 2 whole n's. So 2n is equal to 180. And I can do it that way. Then I can divide by the 2 on both sides. And I have n is equal to 90. So I already know what one of them is, because one of them is just n. So that is also x, is that one. Now, I know what the other two are, both. I don't know why it keeps doing that with the focusing. So I have 1/2 times 90. So I can just do 90 divided by 2, because that's actually what it is equal to. It is still 90 divided by 2, which is 45. So my answer for my other two angles, for both y and z, is 45, because it's exactly the same. Okay? So my 90, so x ended up being 90, y and z ended up being 45. Let's go down to number 5. That one wasn't too hard. That one was easier than the other one was. Except they were trying to mess us up with the halves. Number 5. I need to do, right, okay, so 4y plus 7y plus 6 is equal to 116. So this is 2 remote interior angles added together equal the exterior angle. Keep that in mind. Okay, so I'm going to put together the ones that have the y's. So the 4 and the 7 go together because they both have y's. So 4 plus 7 is 11. So I have 11y plus 6 is equal to 116. I'm going to subtract the 6 from both sides. Gives me a 0 there and 110 here. I have 11y is equal to 110. Divide by 11. That crosses out, and I end up with y is equal to 10. This does not help me currently. Okay. So let's figure out how to do each of these angles. The angle for letter C is 4y. I'm going to plug in the 10, 4 times 10, so it is 40. That's letter C. Letter C is 40 degrees. The angle for letter D is 7y plus 6. So it's going to be 7 times 10 plus 6, or 70 plus 6, which is 76 degrees. Here's where it's starting to get a little, how much were you paying attention to when we described how to figure out what angle they were referring to? Angle DEC. The middle letter, that E, is what tells you what point we're working with. The C and the D tell you the lines that are connecting, but the connector, that right there, that is E, okay? So we're looking for the E on there, and then we're looking to see which two lines we're talking about. It just so happens that it is the last interior line, the last interior angle. That's the one that we're actually looking for. So there's a couple ways of doing this. We could either go back to what we were doing previously, like on this page where we were going, okay, so let's add up all three of our angles and then get 180. We could do that. I'm not going to do that. I'm going to take what I know of the line, a line, just being equal, and go x plus 110 is equal to 180, because the 110 is the other half of that line. So I'm going to subtract 110 from both sides. I get a 0 there, and I get a 70 there. So I end up with that being equal to 70 degrees. Okay? Number 6. Let's try this one. Do I have enough space? I don't think so. Let me get another sheet of paper. Okay. Number 6 is 18z plus 3 plus, sorry, not 15z, 5z minus 3 is equal to 161. And I need to put these inside parentheses. All right. Sorry. I'm going to put my z's together first. So the 18 plus 5, that has us at 23. And then plus 3 minus 3, because I'm just going to put the numbers together. 3 minus 3 is 0, so I don't even need that. Equals 161, so I am going to divide by 23 because it was multiplied before, so now I'm just going to divide it. And 161 divided by 23 is 7. So z is equal to 7. Okay, so for angle L, now we need to go through and do all of our separate angles. Angle L is 18z plus 3. So 18 times 7 plus 3. 18 times 7 is 126. Plus 3 is 129. Angle M is 5z minus 3. So 5 times 7 minus 3, so 35 minus 3 is 32. Done. Angle LK M. Once again, we are at the interior angle for the last one, where we had been using the exterior angle. So I am going to go x plus 161 is equal to 180 degrees, and I'm going to subtract 161 from both sides. And 180 minus 161 is 19. So it is 19 degrees is our final angle. Number 7, describe the relationships between the measures of angles in a triangle. All they want there is all 3 angles are equal to 180 degrees. Okay, I think you can do the rest yourself. So, have a good day. I'll see you again another day.